Welcome to all. Just for information, I already uploaded, I made a note here, 346 classes. Of course, in the YouTube you can see 346 videos. I told I never call this as video, it is a class. So 346 classes already over. Today's is 347 and this will be the last class I am uploading in random order. Of course, one of the class systematically uploaded there, which one? SFD and BMD. That is systematically uploaded, more than 130 classes. Others all, when I take a class here, either for RCC or steel or strength of materials, structure analysis or finite element method, what I do is, some important part I will upload in the YouTube. So those who are in the group, they can refer there and they can preserve it. You see, it will not be deleted. Therefore, now I decided not to do such uploading once again, because from tomorrow onwards, but don't expect tomorrow only, I have to make ready now. I am going to start structural engineering education in systematic order in YouTube. Starting will be engineering mechanics. After that, strength of materials, structural analysis. Then I will decide later for applied subject, RCC, steel, pre-stressed concrete, or advanced structural part, matrix method, or finite element method all. Depends upon what response I get. See, now, here, usually when I start a class, if it's something new, I write heading big letters. Today, not writing big letters because space problem. See, lot of calculation. Therefore, somewhere there I wrote. First you do one thing, write big letters. Numerical examples for flexural analysis of cross-section of T-beam. Means how to find ultimate MR for a given cross-section of a T-beam. Okay, that heading you write. Because when you write something, always there will be a heading for it. Write the heading. Okay, start now. Everything is over. Just to give information for you, I will tell the procedure once again, without seeing the board or without seeing anywhere, looking at you only. See, what you do is, I will briefly tell full procedure, not more than 5 minutes. Now, some people will tell, oh, he came by-hearted. No by-hearting. Everything I can see. How I can see, I will tell you it later. See, there is first question. This is question 1. Very, very easy. That's why I prepared on the board. Second question is medium. That also I will prepare on the board. Third question is, question number 3 is the little lengthy question or most important. It covers all the cases. That I will write in front of you. So, for second question, before I start the question here, I will set the question and note down the value somewhere there. But third question, I will get the value in front of you only. Now, I will tell an example for you. Why by-hearting will not work out? How much time you mug or by-heart like that? It will not stand. Suppose you want to tell somebody, you are in the house, somebody is coming from outside. You want to give him instructions, he is driving. He came to a particular place. What do you tell him? Oh, you reached there. He will tell, I can see so and this one. Take left turn. From here you are telling in the house. After some time you will tell, again one junction came, what shall I do? What do you can see? I can see that one. Okay, take right turn. Then one more, come straight. Take left, again take left, take right. That way you give instruction. Finally you can direct him to the house. You are staying in your house only. How you are giving instruction? Because inside your mind, you can see all those things. There is one thing important. If you want to tell somebody or explain somebody some details of a place, in your mind, the place photo will come. Without that, you can't tell. Suppose you are in the house, you want to talk something about office. Office picture will come to the mind. See, main gate, entrance, where you sit, all will come. Therefore, these things all don't by heart. It is actually very bad. I am so weak in by hearting. See, I noted down the video class number. Sorry, see, now I forgot it. 300 and, see, gone. Gone. I don't remember now. Some will tell, if you are forgetting that much, how you handle class? I tell I will forget numerical values or which are empirical, etc. I may forget. Anything which is systematically derived, I will never forget. It is like everything is known to me. Okay, now, procedure. See, don't see here. See here means this numerical. Breadth of flange, depth of web, breadth of web, overall depth, effective depth, AST, FCK, Fy and XU max by D are data. Now, little fast I will tell. First, locate neutral axis. Neutral axis can be in the flange or it can be in the web. If it is flange, XU is less than DF. If it is in the web, XU is more than DF. But if it is in the web, when XU is more than DF, there are two types are there. One of the type is compressive stress in the flange is uniform. That is, DF is less than 3/7 XU. Second type, type B, is non-uniform stress in the flange. DF is more than 3/7 XU. So what you do is, always any question when you solve, first try neutral axis in the flange. If it clicks, okay, done. See, your question number 1, it will click, you see here. Assumption of neutral axis in the flange is correct. Somewhere I wrote, where here, see, is correct. Happy, over question. Suppose you fail. Fail means not that failure. What assumption you make in the flange is wrong, consider in the web, that is XU more than DF. But two types are there. First, assume type A, consider uniform stress distribution in the flange. Verify the assumptions after you get XU. If the assumptions are verified, correct, over. Proceed further for ultimate MR. Suppose assumptions are wrong, or it is what assumption you made of uniform compressive stress in the flange with XU more than DF is wrong, consider neutral axis once again in the web. Why? Flange is not there. But this time consider or assume non-uniform stress in the flange. It will come correctly last time. Why? No more cases. That way proceed further. So start. Consider neutral axis in the flange, XU less than DF. When neutral axis lies in the flange, T section is analyzed similar to a rectangle section of width B equal to BF. Equate C width B equal to BF. Little fast I will tell. When I solve the question, slowly I will do. Equating CU to TU 0.36 FCK into B into XU equal to 0.87 Fy into AST, replace B by BF. Substitute, get XU. Apply limit state check. Compare XU with XU max. Decide XU to be continued. Compare XU with DF. If it comes within DF, assumption is correct. Proceed further to find ultimate MR similar to a rectangle section. Replace B by BF. See, based on compression, MU equal to 0.36 into XU by D into 1 minus 0.42 XU by D into BD square into FCK. And in tension side, if you consider based on tension, MU equal to 0.87 Fy into AST into D into 1 minus AST Fy by BD FCK. Replace B by BF. If it is under reinforced section, any equation. If it is over reinforced section, based on compression. You cannot use based on tension. If you use, you have to reduce the area of steel. This is all you know it. Now, that's over. But if you get XU, when you consider neutral axis in the flange, you assume XU less than DF. Suppose it comes more than DF, right? Assumption of neutral axis in the flange is wrong. So neutral axis will be in the web. So now consider neutral axis in the web, XU more than DF. Type A consider, that is uniform stress in the flange, that is DF is less than 3/7 XU. See, I can see here. I can see the DF here. I can see that 3/7 XU. See? Then equate CU to TU. Equation is 0.36 FCK into BW into XU plus 0.45 FCK into BF minus BW into DF equal to 0.87 Fy into AST. Not by our trade. I can see that one. How compression force equal to 0.87 Fy into AST. Substituting, get XU. If it comes more than DF, assumption of neutral axis in the flange is correct. Then calculate 3/7 XU. If DF comes less than 3/7 XU, that also is correct. Okay, go for ultimate MR. By chance, assumptions are not satisfied. That is, any one of them is not correct. either I will tell later. Because then, consider once again neutral axis in the web. Don't consider flange. Why? You tried in the flange, you failed, came to web with the type A. Now proceed further for neutral axis in the web with the type B. That is DF, XU more than DF, neutral axis in the web, but non-uniform stress in the flange. Therefore, DF is more than 3 by 7 XU. Equation C equate CU to TU. Now what you have to do is use the same equation as last time for web, but instead of DF, replace by YF. So equate CU to TU, 0.36 FCK into BW into XU plus 0.45 FCK into BF minus BW into YF equal to 0.87 FY into AST. Get YF equal to 0.15 XU plus 0.65 DF. Substitute, get the value of XU. Compare this, check the assumptions. It will come correct. Last chance. Okay, then calculate your how to check it. XU will come more than DF and DF will come more than 3 by 7 of XU. Then assumptions correct. Confirmation that the neutral axis lies in the web with the non-uniform stress in the flange. Then find ultimate MR. Before that, find YF by substituting YF equal to 0.15 XU plus 0.65 DF. One condition is there. YF is not to be taken more than DF. Substitute in the formula, get ultimate MR. If you want formula, 0.36 into XU by D into 1 minus 0.42 XU by D into BWD square FCK plus 0.45 FCK into BF minus BW into YF into D minus YF by 2. I am seeing the stress distribution, seeing the force, seeing the lever arm, not by hurting. But one thing, anywhere, either you consider in the flange or in the web, either type A or type B, last time I will tell, the moment you get XU, do not go for assumptions. First to compare XU with XU max. If XU comes less than XU max, continue with the same value as it is. If it becomes more than XU max, cancel, take XU equal to XU max. One statement you have to write. I told what statement? Ultimate MR for a over-reinforced section is taken same as that ultimate MR for a balanced section. Then continue. Therefore, that is called, see, limit state check. Okay, little fast I talked. Just to give you confidence means if you understand everything, you can create wonders. No confusion, nothing. Now do one thing. All I told, go through it. By mistake, I don't think mistake is there because I am telling everything as I see from the eyes. Eyes means inner eyes, not this outside eye. Inner eye. Kannadadalli, ಒಳಗಿನ ದೃಷ್ಟಿ. Andar ka, I don't know Hindi word. Andar ka drishti, something like that. Okay, start. Now, no place to write the question. Now remember, now class start seriously. Up to this much, just I told something. Purpose is not to show how much I know. Purpose is to give inspiration to you. That if you understand everything, all, see, engineering mechanics, strength of materials, structural analysis, then after that one, RCC, steel, pretest concrete, etc. If you understand each and every concept, what level you can reach to give inspiration for you or to motivate you, not for showing others how much I know. People who know me, they know how much I know. And those who are not knowing me, by the class they can make out. How much I will be knowing, they can make out. So I won't talk about that one. Okay, start. Question 1. Every time question I am dictating. See correctly. I will first sit there and dictate. Why? You can, as I dictate, you can see the sketch here. Okay. I will sit here. The cross section of a T section, cross section of a T beam has flange width of 2 meter and thickness of flange of 125 millimeter. The cross section of web is 250 millimeter by 475 millimeter. On tension side, 3 bars of 25 mm diameter are provided at a clear cover of 40 millimeter. Anything else? No. Taking M20 concrete and FP 500 steel, find ultimate MR of the cross section. Little fast I told because you can write something, pause and write. I need not waste time. Dictating in the class means what? In the class, offline class, I will tell a T section. No, it is a recorded one. You can write something and pause. Okay, start. First, Now, one important. First, I uploaded basic requirement. Very, very important. Especially that type A and type B. Then, next part 2, I uploaded procedure. Now, just follow the procedure. So, I will not waste my time once again telling, see, this is DF, this is non-uniform, etc. So, that you can refer earlier. Now, seriously start. One important, see, the width of flange is 2 meter. This is 600. Somebody will tell, when this is 600, this how it can be 2 meter? It will come like this. Yes, if I write like this way here, it will eat the complete board. Therefore, remember, only breadth of flange is out of scale. Remember, make a note. It is out of, anyway, when you calculate using calculator, who wants scale? Out of scale, remember, because otherwise, when I mark 600 here, see, 600, it will come up to here. Full board it will come. Therefore, I can't afford. Okay, you write correctly. I told breadth of flange 2 meter, but we want millimeter, 2000. Thickness of flange or depth of flange, 125. They told cross section of web, 250 by 475. So, 125 plus 475 together, the overall depth will be 600. You have to see, 600 is calculated, remember. Now, tension, this is the extreme compression edge. 3 bars of 25 mm diameter at a clear cover of 40 millimeter. So, effect, now see, breadth, you can write here if you want, not waves here. Breadth, see, those who are systematic. Breadth of flange, BF, 2000. Depth of flange, DF, 125. Breadth of web, BW, 250. Area of the steel in tension, AST, pi by 4 of 25 square into 3, 1472.62. Effective depth D, 600 minus 40 minus 25 by 2. Still, if you want, distance of centroid of the tension steel from extreme compression edge. Okay, then concrete M20, therefore FCK 20 Newton per mm square. Steel tar of grade FP 500, FY 500. For FY 500, X max by D 0.46 required to find ultimate MR of cross section. I think nothing is out of camera. I will verify once again. Yes, nothing is out of camera, no problem. Okay, start. Right, first, see, neutral axis is always green color. Location of neutral axis. I have given procedure. Follow the procedure. That is to find XU. Always first consider neutral axis in the flange. Okay. Let XU be depth of neutral axis from extreme compression edge class. Always first consider in the flange. Let us assume neutral axis in the flange. See, somewhere here. This is XU, this is DF. Therefore, what you are assuming? That is, you are assuming XU is less than DF. Okay. Why? I don't want to. Some will tell, sir, why you wrote black color for XU? Okay. Sometime in the offline class they will tell, sir, color change. What is this? Okay. Now, one statement you have to write. For a T section, see, for when neutral axis lies in the flange, then this is a reason I have not told for you much because time was not there. Anyway, I told you, believe me, but if you think a little, you can make out. Remember, for a T section, whenever neutral axis lies in the flange, T section is analyzed for flexure. Flexure means bending, means ultimate MR. Similar to a rectangular section of breadth B, in the rectangular sections, wherever B comes, substitute BF. Why? See here. Compression side, you can see a rectangle of width BF. There you can see of width B. So wherever B comes, put BF over. Equating CU to TU, this I already told you, 0.36 FCK into B. Write B only here. B into XU equal to 0.87 FYAST in the bracket, B equal to BF. Substitute. 0.36 into FCK 20, BF equal to 2000, XU 0.87, 500 into 1472.62, XU will come 44.69 millimeter. Continue. I told you already, in limit state method, whether single A in post or double A in post or T section or any section, even somewhat like amoeba section, random section, whenever you get the value of xu, you never bother where you are taken neutral axis in the flange or web. That's all secondary. You should never take xu more than xu max. So, see, this is a limited check. I told in the class, this has nothing to do with the T-beam. Remember, this has nothing to do with the T-section. It is universal for RCC limit state method. We have xu max by D 0.46. So, xu max equal to 0.46 into D. It will come 240.35. So, your xu is 44.49 is less than xu max under reinforced. Therefore, make a personal note. When you get under reinforced section, continue xu in the same value what you got, or see xu to be considered is 44.49. See personal note as it is, or last I will tell, less means less, equal means equal, but more means equal. Okay, now come out of limit state method, come right here, see, come out of limit state method, come back to T section, given T section, start. Verify whether assumption is correct or not. We assumed neutral axis in the flange. xu we assumed less than df. Yes, xu came 44.49. Your df is 125. So assumption of neutral axis in flange is correct. You can write here. Therefore, if you want, neutral axis lies in flange. Really lies in flange. Actually not required. Yes. What we assumed is correct. Therefore, proceed further. See, to find ultimate MR. Ayo, okay. Ultimate MR in the same way as rectangle section. Why? Statement, see here. Whenever neutral axis lies in the flange, for T section is analyzed for flexure in the same way as rectangle section, but wherever B comes, substitute BF. Actually, exam you don't have to write. Once you write the statement here, again and again not required. Now, make a note. Go back to rectangular section. Singly reinforced rectangular section. We can find ultimate MR. I don't know why I forgot it. We can find ultimate MR mu by either Cu into A or Tu into A. A means never arm. Okay. If you consider mu Cu into A, this is a formula. I am using IS code formula today. I am not using other formula. 0.36 xu by d into 1 minus 0.42 xu by d into bd square fck. Remember, wherever B comes, BF. Before substituting here, get xu by d. 44.49 by 522.5, 0.0851. Substitute 0.36 xu by d, 1 minus 0.42 xu by d, B equal to BF, 2000, d square 20, 322.6, 10 to the power 6 Newton millimeter, or 322.6 kilonewton meter. Or consider what? You can write here. Since our section is under reinforced, you can use any equation. You can write here. I written there. Your arm. Cos in under reinforced, we can find MR by any one. You can use any equation. I forgot right. Any one. But to make a note, in case cross section is over reinforced section, you should not use mu based on AST, because it will consider steel more than balance section, or you can use it. What you have to do? You have to reduce the AST to that of a balance section. How much AST is provided, you have to partly remove it. Consider only that AST required for a balance section. Why confusion? Over reinforced. See, when the neutral axis goes to the web, we are using only compression equation. So, do one thing. Always use compression equation. Better. See this answer now over. Or consider mu Tu into A. 0.87 Fy into AST into D into 1 minus AST Fy by BDFCK. Actually it is 1.005. Because of 1.005, this will give slightly more answer. Okay. Substitute. But B equal to BF. See, I got 322.9. I got 322.6. 30 paisa in 300 rupees. Nothing. Or you can make a note. See class. Because 1.015 I think, some number is there. If I use that number, it will come back to this number. But nobody will bother 322.6 if you get 322.9. Full mark. Even if you get 323, 324 also, people sometimes give full marks. Okay. Now, ultimate MR over. See, I talk little fast because these are all known to you. But next round, I will reduce the speed. First of all, what I wrote on the board itself is sufficient, self-explanatory. If you go through procedure and also the principles, it is self-explanatory, nothing required. Okay, now I will go to second question. I will write the question details here. Somewhere in the corner, I will prepare the answer before the class. Why? Calculations are there. I do not want to mistake. But that second question has got 2 rounds. Once in the flange, next in the web. But third question has got once in the flange, no, failure. Web type A, again failure. Web type B. That question, to give you confidence, I will not earlier calculate. As soon as I start the class, somewhere here, I will note down the answer in front of you. I will not cheat. Someone will tell, he has written somewhere there. Where somewhere? That is to show you that imagine correctly. I will write the answers here so that it will take not much, maybe some 1 minute or 1.5 minutes it will take. Anyway, by seeing that one, you get the confidence or motivation. Okay, now, second question I will make ready. For the tough question only, I want to show how you can imagine the concept and solve it. Now, second question. I will dictate the question, you write. Find ultimate MR for a T section which has following dimensions or properties. Flange width 600 millimeter. Depth of flange 120 millimeter. Width of web 400 millimeter. Overall depth of the T section 900 millimeter. Tension reinforcement 8 bars of 25 mm diameter in 2 rows of 4 bars each at a clear cover of 40 millimeter and a clearance of 32 millimeter between the 2 rows. Concrete M25. Steel, once again, not once again, sorry, actually there is no once again. Steel, tar of grade FE 500. Over. This is a question. Start. I don't have to explain. They are given 600, 120. Last time this depth given, adding them you get overall depth. This time directly overall depth. In the offline I will ask. So you can find this. Yes sir. Why you want it? Why you want it? Not required. We require depth of flange and D. Why you want it? Okay, find if you want. Waste of time. Okay, start. Breadth of flange BF 600. Depth of flange DF 120. Breadth of web BW 400. AST. See, pi by 4 of 25 square, 4 plus 4, total 8 bars into 8. 3926.99 mm square. I want section at least once to be over reinforced. That's why. Over. Effective depth D. Be careful now. 2 rows are there. Consider 2 centroid of the steel. 900 minus 40 minus 25 minus 32 by 2. These all I explained in earlier classes. You should go through. See, actually you should study all the classes uploaded by me. Even though I upload partially RCC, important parts I uploaded. It is really useful for everybody. Okay, our M25, FCK 25, FY 500 because FP 500 still given, X max by D 0.46. Required to find ultimate MR of the cross section. Right. Location of neutral axis to find XU. Let XU be depth of neutral axis from extreme compression edge. Class. Usually in the offline class I will ask. Last time came in the flange, correct? Yes. So this time it should come where? Sir, web. Why? I will tell 100 question I will do. It will come in the flange only. Someone will tell, no sir, you will not do that way. Why? Time waste. It may come in the web. Anyway, they know that it is coming in the web. Otherwise, why should I waste time? It is called waste of time. So when I am covering multiple cases, I will correctly cover in order. But I will tell, suppose a question given in the examination, sir, then we don't know. Oh, yes, you solve the question as if this is not question 2, this is fresh, just now class started. You solve as if just now class started. Okay. Class, we do not know where is neutral axis. So first, as usual, consider neutral axis in the flange. Okay, start. Let us assume neutral axis in the flange, xu less than df. Same statement I told last time. If the neutral axis lies in the flange, T section is analyzed for flexure. Similar to a rectangular section, replace B by BF. Equating Cu to Tu, put the equation B equal to Bf. 0.36 FCK, 600 berth of flange, into xu equal to 0.87 FYAST. You get the value of xu. Now, 1 minute. Make a note. When I was changing the value, I saw 200 here for the last question. Actually, last question, breadth of flange was 2000. I told 2000 only. I solved also for 2000. But while writing, maybe I forgot 10. See, this is not technical mistake. I don't know. When I rubbed and changing the values, I saw 200. I was wondering, why 200? It was 2000. So, go back to the previous question. By mistake, if I written 200 there, change it to 2000. Otherwise, you won't get that answer. This is called misprint. See, I told you, writing some value, if little this side, that side over, or calculation mistake, some spelling mistake. I am not very good in English spelling. I am an Indian. My mother tongue is not English. So I started learning English only after 5th standard. A, B, C, like that. Spelling, sometimes confusion. I don't give weightage for that one. Usually, grammar mistake, I never do. But sometimes it may happen. Suddenly, some grammar mistake. Don't make issue of those things. Technical mistake, if it is there, let me know. Technical mistake. I never regretted so far. See, last time what I told is wrong. So this time, please correct it. It never happened in my teaching here. Therefore, right, XU came 316.34. I will ask the students immediately question. See, depth of flange is 120. Correct? Yes, sir. Our XU came, some siren is coming there. Hope it is not disturbing. XU came 316. So we assumed that your XU is less than 120. So is the assumption correct or wrong? Major people will tell, sir, wrong, sir. But there are students who will tell, sir, 1 minute, sir. That comparison is a T-beam part. We got XU. Therefore, before you go to T-beam, first you will finish our limited check. Yes, see, I told you. Write the note. Now, verifying assumption is only after you confirm XU to be considered. Limited part. So, forget about T section. XU max by D 0.46, get XU max. It came 376.74. Your XU came 316.34. Oh, once again, XU less than XU max under rainbow section. XU to be considered is 316.74. Okay, as it is. Someone will ask them, sir, you told over rainbows. Wait 1 minute. This assumption is wrong. When I go to web, it will come over rainpost. Sir, how you know it? You never bother how I know it. I know how to set a question. And also, when I see a question, I can make out where neutral axis will come. They will tell, okay, sir, you don't bother about those things. Okay, start. Class. Now, XU to be considered is 316.34. Now the time has come. You go back to T section, verify whether your assumption of neutral axis in flange is correct or not. You assumed neutral axis in the flange. XU less than DF. But unfortunately here, XU came more than DF. How much DF? This time DF is 120. I am changing the values. XU you got 316.34. Therefore, assumption of neutral axis in flange is not correct, is wrong. Is wrong. That is, you can tell neutral axis will lie in web. Okay, camera problem, I'll check it. Neutral axis will lie in web. Okay, no problem. I cannot see properly. Okay, neutral axis will lie in web. Where is it? 316.34. Oh, that side I would see. I am seeing some other place. Okay. Something happens. Now, how to proceed further? So, now remember, this all gone. Our assumption of neutral axis in the flange is wrong. Means neutral axis will be in the web. Okay, start. Now, the little space problem is there. I have to manage in the available space because I do not want to cancel this one. It is required for next question also. Okay, start. I will write in front of you. So, we assume neutral axis in the flange. It is wrong. It is in the web. Now, write a note if you want, class. Now consider neutral axis. See, the procedure is given. Now consider neutral axis in the web. When neutral axis comes in the web, there are two types are there. Type A or type B. Always in the systematic order, first try type A. If it clicks, okay, well and good. Suppose assumption is wrong, go to type B. So, class, you write. Already over now, class over. Consider neutral axis in web. That is, you are assuming your XU is more than DF. Okay, then one sketch, then also make a note here. This is your case 2. One personal note you can write. This is your case 2 in the procedure. Don't write in the examination case 2. Also, you should write if you want. Now, when the neutral axis lies in the web, doubt comes. Type A or type B, first try type A. Therefore, also, let us assume uniform. I'll write somewhere here. Assume, see, uniform. Why space? Because for next time, non-uniform. No, uniform only. Okay, correct. Assume uniform compressive stress in flange. That is, your assumption is that this I will not explain. Your DF is less than, sorry, if someone tells, sir, this is not clear, you better not come to any of my class in future. After that much explained in the part 1 principle, then again explained in the procedure, so much explanation done. If still you have difficulty, I will tell I am not a person fit for teaching you. Okay, that is second assumption. If you want, write a sketch. Okay, if you want, write a sketch. Better. I'll write here. Now this portion I have to remove now. That's the main problem. Okay, I'll manage. It will make a better. Space is important. Okay, this is the little small I'll write. Still, why that much space I can't afford to waste. Okay, small. See, this is your DF. Then BF is not required. This is AST. Okay, you are assuming neutral axis here. This is your XU. This is all I told earlier. I am wasting time. So XU is more than DF. Or you can see here, we are assuming neutral axis in the web only. And stress distribution diagram, see. Little more, okay. Then I told you, if you remember, this is the junction of rectangle and parabola. The junction distance is 3/7 of XU. I told very clearly, 3/7 of XU. 1 minute, camera. Whenever I go to extreme end, I get doubt because, oh yes, beautifully visible. Little more space is there. Okay. 3 by 7 XU. Okay. Neatly I have not done. That is what? See, your full DF. This is the flange. This flange will come somewhere here. You have to understand. Means full flange, everywhere, stress is uniform. How much this one? Actually not required. 0.45 FCK. Okay, write this sketch. Okay, now write. Equating. Make a note once again. One more note. Previous one note you write here. Important. Do not take XU equal to 316.34. You should write here. See, one note you have to write here. See, one note here. Since our assumption is wrong, the value of XU calculated considering neutral axis in flange is also cancelled because new equation is there. So all you can write, all previous calculations gets cancelled. Everything fresh calculation, but XU max will remain same. Okay, start. Note. Not already told. Once again you have to find XU. Write a note. Then, okay, note I will write here. You write. Equating. Now this is BW, not required. Equating CU to TU. If you want, you write resultant compression force, tension force. See, 0.36 into. Sorry, I am using original equation. Okay. 0.36 into FCK into BW into XU. This all I explained for you last time, including the hint I given. XU plus 0.45 FCK into BF minus BW into DF equal to 0.87 FY into AST is the formula. 1 minute. Check the camera. Some will tell how many times he is checking. Because once I write everything, later if I come to know that it is not visible, I have to conduct the class once again. Okay, start. This is equation for what? XU, correct? 0 FCK into BW into XU plus 0.45 FCK into BF minus BW into DF, correct? Substitute. Substituting 0.36, see, because of space problem, I am writing little lesser. You see in the laptop and make a neat fair copy. They write big letters. 0.36 into FCK 25. Now you require BW, not BF. I told you earlier how, because now for analysis what you are doing is you take rectangular and offset. See earlier class, BW to 400 into XU into XU, correct? Point FCK into yes, correct. XU plus 0.45 FCK 25 into BF minus BW 600 minus 400 into depth of flange is 120. Again space problem may come. Equal to 0.87 FY is 500 into AST 26.99. Solving this equation, you once again get the value of XU. XU will come. I let the value of XU after checking the camera. See how much effort I am putting, how horrible, frustrating if it goes out of this one. No. XU I am not calculating because I told before I started recording, I noted down 399.51 millimeter. It will come. You can see somewhere there. Next time question I am not writing somewhere there. Just to give you confidence. How you can imagine and do it. Even see, when I wrote that number also, I took my calculator and wrote. I have not written any paper. Okay, millimeter. Start. Now I will ask the students. Now tell me, your XU you considered in the web. You are assuming XU more than DF. You got 399. How much DF? Sir, 120. So assumption is correct or not. Compared to last time, less number of people will tell correct. More people will tell, sir. What? Sir, no sir. You cannot proceed further unless you decide under rain post, over rain post, and what XU to be considered. Good. So I told you, now do one thing. Do not bother about T-beam. Write a note here. First, whenever you get XU by limit state method, first you get what? XU max, right here. Therefore, your XU calculated, see here, your XU calculated equal to XU calculated value of 399.51 millimeter is XU max. See, once again not required. Why? It is not depending on neutral axis. 0.46D already calculated is more than, at least once it came, more is red. When I want black, black is not coming. Okay. Is more than which one? XU max. XU max is how much? 376.74. Now, space problem, I will dictate, you write. Therefore, cross section is over reinforced. Danger beam. Over reinforced. Now, one statement you have to write. Okay. Usually I write in the class, but you should write now. I will dictate. This you know it. First is personal note. We should not consider XU more than XU max. If XU comes less than XU max, take XU whatever you got as it is. If XU equal will never come. In case XU comes more than XU maximum, you should not consider XU calculated. You should take XU equal to XU max. Write a personal note. Now, real note you are to write in examination if you want. Cross section is over reinforced. Ultimate MR of over reinforced section is, you should write here. I am not writing. Ultimate MR of over reinforced section is limited to that of a balanced section, that is for XU equal to XU max. Therefore, for calculating, for proceeding further, value of XU to be considered. Now see, that color gone. Therefore, value of XU to be considered equal to XU max. XU max equal to 376.74 millimeter. Therefore, now when you continue, this XU will get cancelled. This XU you have to continue. This I told so many times earlier. So if you are not going through all the classes, this is what happens, confusion. Okay, now, yes, now we will go for verification of assumption and check correct or not. I want some space. I will use this space. Why? Because this statement will come once again for next question. I will rub here. Why? I will do in front of you only. Okay, no problem. I will rub this one. Before that one, any requirement is there? AST is not required. D is there. 819. D is came there. Yes, okay. Sufficient. Okay. I will rub this question. This space I will use for continuation. Then last question. Okay, start. Now, right here. Now, one note if you want, personal note. Now time has come to verify our assumptions. Start. See, we got XU more than DF. What is the XU value? Don't tell XU equal to, this is cancelled. 376.74 because limiting value 376.74. DF is 120. Okay, and also 1 minute before that one you got one thing over. Okay, one you got. Okay, then next also calculate 3/7 of XU. Okay, red color to make more clear. 3/7 red color. 3/7 of XU. 3/7 of XU equal to 3/7 of 376.74. That will come 161.46 millimeter. 46 millimeter. Right. Therefore, your DF. See, we assumed that DF is going to be less than. We assumed XU more than DF. That is correct. Also, we assumed what? DF is going to be less than that value. Yes, it is less. DF is less than 3/7 of XU. How much DF? Actually, writing is not required. DF is 120. 3/7 XU together equal to 161.46. Therefore, assumption of neutral axis in web with uniform compressive stress in flange is fully correct. Okay, stop. Therefore, over. One personal note. Happily proceed further to find ultimate MR. Now you should write ultimate MR for case 2 type A right here. Therefore, proceed further. Ultimate MR. Space problem is there. Mu equal to, I will write as much possible, 0.36 into xu by d into 1 minus 0.42 xu by d into bw into d square into fck plus 0.45 fck into bf minus bw into df into d minus df by 2. See, I am neither seeing here nor seeing there, only writing 100% not by hearted. Okay. Before substituting, find xu by d. Actually not required because your xu by d equal to xu max by d only. When you calculate, sometime it can be different. 376.74 divided by d. Where is d? 819. It will come surely 0.46. Okay, now I will sit and substitute. Substituting, hope it is mu equal to, see, 0.36 into 0.46 into bracket 1 minus 0.42 into 0.46 space problem into bw. How much bw? bw is, bw, 1 minute. I forget so fast actually. bw is, these, see, numbers, see, you can make out how fast I forget everything. bw is 400, see. I am not good in by hearting. Continue into 400 into 819 square into 25, still not over, plus 0.45 into fck into 600 minus 400 into bf minus bw into df is 120 multiplied by d, 819 minus 120 by 2, you get ultimate MR in 10 to the power 6 Newton millimeter. I noted down somewhere there 1101.1 1101.1 10 to the power 6, or you can tell 1101.1 kilonewton meter is the ultimate MR. Over. Question number 2 is completely over. Remember, I will tell next time. Now start question number 3. What I will do is question number 3, I will write the question here, all the values I will calculate in front of you, but not during the problem. I got a trick of calculating. So I will calculate and prepare those numbers, which is hidden numbers, partially hidden there. This time full open. If you want, I will turn the camera and show you nothing is there. Students will tell, sir, no sir, we believe you. Okay. I will start now question number 3. Most important question. I need a calculator now. Okay. Now, question number 3, I will dictate because space problem. I will dictate somewhere standing here. But as I dictate, I will show it here so that you copy the question after the class is over. Okay. A T section has flange width of 750 millimeter and depth of flange is 100 millimeter. Web has width of 300 millimeter and web has depth of 700 millimeter. It is a web depth. Therefore, now only. Oh, no. Later. Because my question means question. Tension reinforcement consists of 4 bars of 25 mm diameter at effective cover of 60 millimeter. Taking M20 concrete and tar steel of grade Fe415, find ultimate MR of the cross section. So, I think everything clear. See, this time 700 given, 100 given, 800 calculated. Last time clear cover all given. This time directly effective cover given. You can make a note. Actually not required. This is directly given effective cover to tension reinforcement. So your D will be directly, change it now. See, 800 minus 60 equal to 740. Other things all you know it. Why unnecessary waste the time and prolong the class. Okay, BF, DF, BW, AST, D, FCK, FY, etc. over. Now we will solve. But I will do one thing now. Just to give you confidence. How you can imagine everything here and solve. Okay. The way usually see when this see question number 3 is the lengthiest question. Why? Flange will fail. Web uniform stress will fail. Finally non-uniform will come. So 3 rounds are there. Actually if you solve fast, not more than 10 minutes. Therefore, all this I have to adjust now. Adjust means what? I set the question so that what? I can make out how to drag the web. Neutral axis will be somewhere here now. So usually such questions what I do is in the corner there, you know all these things. I stand here before the recording starts, note down the values, calculate standing here and write. This time I will calculate just to give you copy. I will use green color. Somewhere here I will write numbers. Or if I write here, 1 minute. Will it be obstructing? Let me see. Just to give confidence for you. That is the way you imagine in the mind so many things. If you imagine structural concept, how confidence or how much level you can reach, just to give confidence for you only. Okay, no problem. Space is there. Okay, I will write this side. I will tell what I am doing. I will assume neutral axis in the flange first. Do it. D 740. That is 355.2. So over. Assumption wrong. I took in the flange. I failed. Now I will take in the web. In the web I will take with uniform stress in the flange. 750, 300. Okay, 4 of 25. FY 4 on 5. $140.70. No, limit okay, 3 by 7. Into 3 by 7. 60.3. You don't worry, it will come no later. Again failure. One more try. Now I will take neutral axis in the web with the non-uniform stress in the flange. Little lengthy equation. It will take some 30 seconds, 20 seconds. $400. I want difference of 750 and 300, but that is outstanding. $69. Ayo. It light. It looked like 59. Actually, I kept me out because what happens is I can make out that much. 3 by 7 is more than 60. I can make out. Okay. Because 161, 69.02. 3 by 7 of 161.04 is 69. See, I can make out immediately. Now, assumption correct. YF required. Everything over. Ultimate MR also I will calculate. Imagining terms. 0.36 into XU by D required. For that one. 151.04 divided by D how much? D is 740. 0.2176. So ultimate MR is 0.36 into XU by D into bracket 1 minus 0.42 into XU by D is 0.2176 into BW is 300 into D square is, where is D square? 740 square into FCK plus 0.45 into FCK 20 into BF minus BW difference is 450 into YF is only 89.16 into bracket 740 minus YF by 2. That is, where is YF? 89.16 by 2. 484.97. 97 is the MR. This answer I got. You can imagine 3 rounds of calculation, nothing written and only imagined. How, like someone coming to the house, you tell take left turn, take right turn, come. Everything is in the mind, you can see it. Just to give you confidence only. Okay, now start. I won't tell further. Don't see this number now. This is for my reference. You solve. Okay, start. Now I won't waste time. First, same statement you write. First, let us assume neutral axis in the flange. Substitute, same story. Once again, all the story you are right. Replace B by BF, substituting 0.36 into XU, FCK is 20. Breadth of flange is 750. XU equal to 0.87 into 415 into AST is 1963.5. XU will come, I already calculated, 131.28 millimeter. It will come. In case wrong means okay. See, sometimes human being, I may also make mistake, but I am careful. But actually I can make out correct or wrong. See, if abnormal value comes, I can make out immediately something wrong. Okay, XU comes, I am not calculating now. In front of you, I already calculated. See, I am here now. I had reached here. Not big work. 131.28. Now, before you proceed further, T-beam or rectangle beam, this beam, that beam, first compare XU by D with XU max by D. XU max by D is 0.48. I am using black color, so this will be 0.48 into D, 0.48 into how much? 740. Your XU max will come 355.2. Therefore, your XU you got how much? I should see here. I am not supposed to see there. 131.28. XU you got 131.28 is less than XU max of, see color, 355.2. Cross section is under reinforced. XU to be considered is how much? As it is. How much as it is? As it is means what? Whatever you got. 131.28 millimeter. Okay, now we got XU value here. Yes, under reinforced came. That XU correct. Now time has come to verify the assumption. Start. How to verify? See. Now to verify assumption. XU, how much you got? We got XU 131.28 millimeter. 28 millimeter. Depth of flange is 100 millimeter. 100. Therefore, assumption of neutral axis in flange is wrong. Why? Because flange has got only 100 depth. XU came 131. So it is wrong. Neutral axis will be in web. Okay, start. Class. In the offline class, I will ask, see last time type A came. This time, sir, type B will come. No, don't tell that way. Who knows? Anything can come. But of course, type B will come because I can't waste time. So you should do systematically. Right now you are not knowing which will come. So what you do? First try type A. Last time you succeeded. We'll see this time. Consider neutral axis in the web. XU more than DF. That is case 2. Also let us assume uniform stress in the flange. Same statement. Same equation. Substitute 0.36 into. Substitute now. See, this advantage of maintaining the previous values. 20 into BW is 300 into XU equal plus 0.45 into 20 into BF minus BW is 750 minus 300. 750 minus 300, close the bracket, into 100 plus is equal to 0.87 into 415 into AST. Where is AST? 1963.5. Your XU will come 161.8 140.70. It will come 140.70 millimeter. Okay, now again compare. XU you got how much? 140.70. 140.70. Limited check. XU max is already calculated 355.2. So X and cross section is what? XU is what? Now the XU is less than XU max. Less than XU max. So cross section is under reinforced. Therefore, right, XU value to be considered is, for all future calculation, XU to be considered equal to same 140.7. Less means less millimeter. Okay, now time has come to check the verification. Up to here I did. Now I remove this portion. Why? Okay, now I can remove this portion also, because why not required? 1 minute. I'll remove. How much not required? I'll remove. 100%. This is not required now. This is also not required, correct? Yes. Then XU max, I remember. If I require, I got it here. 355.2. This is also not required. Now I can save the space. I don't have to worry about space. This is also wrong, already over. Okay. I think now space problem is not there. I'll continue. See. Then I'll remove that also later. Okay. Actually, I clean in between. During recording, I don't clean because I don't feeling little tired now. So I don't want to go there, stop the recording, again come back and write. Okay, straight. See, these things are all hardly meant for learning purpose. Some will tell little stain is there. Let it be there. Okay, now 100 rubber is 100 ago. 100. Okay, now right here. We considered neutral axis in the web with uniform stress in the flange. Verify it. See, XU. Okay, same color. Why? No change. XU you got how much? 140.7. 0.7 is more than depth of flange. How much depth of flange? 100. Therefore, your neutral axis in web, XU more than DF, that assumption is correct. Now, one small note for you. Some rare cases, XU can come less than 100. Rare cases. Suddenly people get what? They got stunned. Sir, I considered in the flange first. XU came more than 100. Now I consider the web first, type A, it came less than 100. Shall we go back to flange? No. You can't go back to flange because, why? You make a note here. By chance, if you get more than less than 100, it means that the assumption of neutral axis in the web with the uniform stress is wrong. Go to other case, last case. Don't go backwards. Make a note, 100. And also you calculate what is red color. 3/7 of XU. 3/7 of XU equal to red color, okay, not required. 3/7 of XU is 140.7. 140.7 equal to, I already calculated, 60.3 millimeter. 60.3 millimeter. Therefore, see here, your XU came, see correctly here now, XU came more than DF. Okay, DF is black color. XU came more than DF. DF is 100, XU is 140.7. But your DF, which is 100, is more than 3/7 of XU. The combined value is how much? Combined value is 60.3. But we assumed XU more than DF with DF less than 3/7 XU, assuming that compressive stress in the flange is uniform. Therefore, assumption of neutral axis in web with what? With uniform compressive stress. Uniform compressive stress in flange in flange is wrong. Therefore, right here, what to do? Proceed further. Write a note here. First we considered in the flange. It came more than depth of flange. So it is not in the flange. We took in the web, assuming uniform stress in the flange. That also wrong. Therefore, only one chance is there. Once again consider in the web, but this time consider non-uniform stress in the flange. Okay. I will write here. Therefore, consider neutral axis, or I will do one thing now. This all I will remove. I start fresh from here. Space problem is there. Something fell down. Where is the cap? Pen cap. Because if the cap falls down, if it remains for 5 minutes, the pen will not write once again. That's a drawback of this one. Okay, 1 minute now. These are not required. Okay, not required. Okay. I remove this one. If you want, you can see what happened last time. Now, concluding part of the question. Everything's over now. See, full I am removing. So that there is no space problem now. Neatly I can write everything because this is the most important part. Okay. So what you do is, therefore, right here, let us assume neutral axis. See, once again in web with means what? That means your assumption is XU is more than DF. With what? With non-uniform compressive stress in flange. That is, our assumption is DF is going to be more than, red color, 3/7 of XU. This all explained so much time, I don't know. If you want, write a sketch here. Go here, write a sketch. Just to understand. It's a thick flange I want to understand. Neutral axis in the web only. XU, this is DF. Now you are assuming stress distribution diagram. See, this is the DF level, whereas the junction lies here. Therefore, you can make out now. Now, if you consider the flange, a part of the flange is in the uniform stress region. Remaining part of flange is in, confusion. Feeling tired, that's why. See, I will not make such mistakes. Remaining part of the flange is in non-uniform portion. See, this much is in uniform region, non-uniform region. This is your 3/7 XU. See, understand correctly. You imagine how I got all these values? Not by hearting or what, solving earlier. Okay, start. AST. Okay, now, over. Now, equate, right here. The previous calculated value of XU is cancelled. Now you have to once again find XU for this case. Therefore, that is what? Tell me. That is case 2 and type B. Last time I don't know whether I wrote it or not. Last time when I assumed there, you can write there. Case 2 type A. Okay, start. I write here. Equating CU to TU. Write correctly if you want. Resultant compression to tension force. Formula is 0.36 FCK into BW into XU plus 0.45 FCK into BF minus BW into not DF now, into a new term called YF. YF equal to 0.87 Fy into AST. How fluently I am writing? 0.45 FCK is the average stress or constant stress. BF minus BW is the effective width of outstanding portion, and YF is the depth of the what? It is the depth of portion for uniform stress. And how I got this one? Point sub CK into this area is the force, not nothing. Now see, now before you substitute, where you are right that YF equal to 0.15 times XU plus 0.65 times DF. Okay, but as per IS code, your YF value should not be taken more than DF value. Okay, now start. Substituting, I'll write here now. Substituting, see correctly. 0.36 into FCK 20, BW is 300 into XU plus 0.45 into FCK 20, BF minus BW is 750 minus 300 into YF, on bracket YF, 0.15 into XU plus 0.65 into DF is 100 equal to 0.87 into Fy into 1963.5. I know that number because why, but I want to remember 1963.5 is known to you, but I don't know it is 4 of 20 or no, 25 or 1963.5. Therefore, solving, you get the value of X. Some student has asked in the class long back, sir, one XU comes here, one more XU comes there. First time happened, sir. Okay, so what? How to solve? I told him, I wrote the answer here. See, where is the answer XU? XU will come 161.04. I wrote the answer 161.04. I already got the value of XU. In front of you, I did it. Standing in front of what? You. Did I see anywhere? No, sir. Did I write anything? No, sir. What you did? What I did? Sir, you took your calculator, looked at the problem and got. Can't you at least simplify this one? 1XU multiply with constant again. Oh, yes, sir, we can do. Then when I can get it without writing in the board and I got the value of XU in front of you, at least can't you calculate? Sir, we got confused. Why? Sir, so far XU comes only once. Now XU came twice. Let it come 100 times. So what? It is a linear only. It is not a quadratic equation. It is a linear equation only. Okay, start. XU will come. I already got it. 161.04. See, you check it later. If wrong means by chance if it is wrong, correct it. 0.4 millimeter. Okay. Now, immediately, right here. Limit state check, but limit state check actually not required because anyway right here your XU which you got 161.04 is less than XU max. XU max is 355.2. Therefore, cross section is under reinforced. Value of XU to be considered, actually it's a waste of time now writing, considered equal to same as it is 161.04 millimeter. Make a note. Okay, now proceed further to find ultimate MR of the cross section. Okay, now I will remove this one now. Space required for me. Now to find, see, this all not required now. Oh, sorry. So I see, I forgot the most important. Still we are not verified the assumption. Okay, now start. Now, time has come. See, I forgot suddenly. If I rub the board, gone case. Time has come, right, person note, to verify these assumptions. Start. We got XU. See, suddenly forgot. Otherwise, once again at record, we got XU. How much? 161.04. It is more than your DF. DF 100. Therefore, this is correct. Then, also, your red color. 3/7 of XU equal to 3/7, no, it is not. 3/7 of 161.04 equal to 69.02. Correct? Correct. 69.02. Therefore, df, which is 100 millimeter, is more than 3 by 7 of xu. Answer is here only. Therefore, our assumption of neutral axis in the web perfectly correct. Non-uniform stress in the flange df more than 3 by 7 is correct. Right. Therefore, assumption of neutral axis in web with non-uniform compressive stress in flange is fully correct. Just write correct. Correct. Over. Now, he is correct. Okay, neatly. Important. So much you struggled. He is correct. Write a note here. Therefore, proceed further to find ultimate MR of the cross section. I will do one thing now. I will rub this one because I want more space. Now nothing required. Start. Lastly, closing part. Therefore, this time I won't use the okay, a little bit color. I'll maintain. Right. Wrong pen is coming. Ultimate MR mu equal to 0.36 into what? xu by d into bracket 1 minus 0.42 into xu by d into bw d square. See, as I am writing, I am seeing the compressive stress block, I am seeing the resultant force, I am seeing the lever arm, and that's how I am writing, not by hearting. Plus 0.45 fck into bf minus bw into yf into d minus yf by 2. Okay. Before you substitute, first calculate yf. See, first substituting in yf equation, in yf equal to 0.15 times your xu, 0.15 times xu plus 0.65 times df, you get 0.15 into xu. Where is xu? 161.04. 161.04 plus 0.65 into df is 100. I got 89.16. 89.16 millimeter. Anyway, right. As per IS code, YF is not to be taken more than DF. YF you got 89.16, DF is 100. Therefore, YF to be considered is same. Considered equal to, as it is, how much? 89.16 millimeter. Make a note here. Some rare case when you substitute, YF can come more than DF. Suppose you got 103.8. Then you cannot take more than 100. Then what you do? Not 100, depth of flange. Then that value cancelled, take whatever is a DF over. Now, before substituting, get xu by d. Why? Because that also you require. xu by d equal to xu 161.04 I. 161.04 divided by d is 740. That also I got 0.2176. 0.2176. Why green color? As it is xu over. Now, actually I can stop the class. Substitution, I will do it now in front of you. Nothing is there. Substituting ultimate MR of the given T section, mu equal to 0.36 into xu by d, 0.2176 into bracket 1 minus 0.42 into xu by d, 0.2176 into bw is 300 into square of the d. 1 d has gone that side, therefore square of the d into 300 into 740 square fck 20 plus 0.45 into fck into bf minus bw 750 minus 300 into YF is 89.16 into 740 minus 89.16 divided by 2. You will get answer. I think correct. If wrong, change it. By chance, if any value is wrong, change it. Don't put a comment there. Answer is wrong like that. Newton millimeter. One homework for you. You have to write. That is 484.92 kilonewton meter. Hope you will write it. Over. Now, ultimate MR calculation for T section systematically covered, so that any question given, you follow the procedure given by me. If you click in the first trial, okay. In the flange. See, 3 steps you have to go. Go to first step. Succeeded, thank you, over. Failed, go to second step. Succeeded, thank you, over. Or last step, sometime in the class I will tell. Write main examination. Passed, happy, leave it. Otherwise, go attend supplementary exam. Passed, safe, over. Fail, once again next time, one more examination. Some student will, now you got some other exams, or what? Improvement exams all. That's all nonsense. If you fail within 15 days, they conduct one more examination. That's how education standard has gone down. Okay. Anyway, I forgot to tell you, over. Now onwards, I already told you, last uploading in this somewhat not order, except one course, SFD BMD and mathematical concept class. Others all, I uploaded the classes which I am taking for regular batches. Now onwards, I will first announce the scheme, what I am going to do. I told you, I want to teach, I want to give structural education, if possible, to the entire world. How much I know, I will show them to everybody. I will show what level I can teach the subject and how much you will gain. So wait for some time, I will start uploading. If you are not subscribed, subscribe so that you get notification. I never ask anybody to like. Like should come from here, not by telling. Sometime online classes you can see people tell, come on, like it, come on, like it. Hit the like button, hit the like button. That is their problem. Such a gimmick I never go. I never believe in gimmicks. You believe in true education. Thank you very much.